Okay, in this section, we're going to be talking about a different function called the absolute value function. The absolute value function is written as y equals the absolute value of x. It's got bars around it. And we've talked about absolute value in previous courses. And if you don't remember what all absolute value is defined as the distance that a value is from zero. And since distance is always positive, pretty much all this absolute value function does is makes numbers positive. Okay, so it says complete the table below to graph the function. Okay, let's complete our absolute value table. If x is -3, the absolute value of that would be +3. If x is -2, the absolute value +2. The x is -1, the absolute value is +1. So anything negative, it makes positive. If it's 0, it stays 0. If it's 1, 2, and 3, it stays because those are already positive. When you graph this, you get this shape. When you plot -3, 3, -2, 2, -1, 1, 0, 0, 1, 1, 2, 2, and 3, 3, you see what happens. You end up with this shape. Let me connect my dots here. Now, as far as domain and range goes, domain into the absolute value function, you can find the absolute value of anything. So your domain is going to be all real numbers from -infinity to +infinity. You can just put real numbers out there if you would like to. Your range, however, notice there's no graph down here. Your graph starts here when you're talking about your range, and it goes up forever. So your range is going to be all values from 0 to infinity, or you can just say y is greater than or equal to 0. Either way, that's going to be your range. The graph looks like a V shape every time. The turning point of that V shape, that lowest point, we're going to call a vertex. Okay, let me scroll up. Let's talk about actually graphing by a table. To create a table of values, it's best to place the vertex in the middle, then include the values on both sides. Find the x value of the vertex, set the expression from the inside of the absolute value bars equal to 0 and solve. That's how you're going to find it. Place this value in the middle of the row of your table, then number up and down to complete the table. And then let's graph. Let's try. I'll show you what they mean by this. Okay, here we go. If you take this and you want to find the vertex of this, and this is not necessary, but you can do it, the stuff inside the absolute value bar, if you set that equal to 0 and you solve it, move the 4 over, you get 4. That's where your vertex for this parabola is going to be located. And since the vertex is kind of that turning point, if you would like to, you can actually put that in the middle and then number it on each side, 1, 2, 3, that'd be 5, 6, and 7. You can see what's going to happen, okay? Now, when I plug in 4, let's go ahead and do that first. F of 4, I get 4 minus 4 is 0. When I take the absolute value of that, I get 0. So my first point on my graph is going to be 4, 0, which is right there. When I plug in numbers like 1, 2, and 3, okay, let's start with 3. We're going to go up from 0. When I plug in 3, I get 3 minus 4, which is -1. The absolute value of that is 1. So when I plug in 3, I get 1. When I plug in 2, 2 minus 4 is -2, and take the absolute value, I get a +2. So 2, 2 is on my graph. And when I plug in 1, 1 minus 4 is -3. The absolute value of that would be +3. So we kind of already know what's going to happen if this is my vertex. And let's confirm it. When I plug in 5, 5 minus 4 is 1. The absolute value of that is also 1. These absolute value graphs are symmetrical. So if you were to draw a line down through here, this would be like a line of symmetry. So I already know if this point's on my graph, I already knew that point was going to be. I already know because of this point where my other point over here is going to be without even plugging it in. And the same thing with this last value. Now, I am going to plug them in just to solidify that. 6 minus 4 is 2. The absolute value is 2. 7 minus 4 is 3. The absolute value is 3, which again gives me these 2 points. So once you find your vertex, if you just plug in the values on one side and remember the symmetry that these things have, then it tells you the values on the other side. Your domain now, you can find the absolute value of anything. Domain would be all real numbers, -infinity to +infinity. Your range, there's no graph down here. Your graph starts here and it goes up forever. So the range there would be all values from 0 to infinity. The next one. Again, let's find our vertex. You can set the stuff on the inside equal to 0, subtract 6, divide by 2, -3 is where your vertex is going to be located. You can put it in the middle. And again, that way your parabola is going to, or your absolute value graph will be symmetrical on each side. I keep saying that word for some reason. So you can count down and count up. It doesn't matter. -2, -1, 0, -4, -5, and -6. When you plug in, let's start in the middle. When you plug in -3, it gives you -6 plus 6 is 0. The absolute value is 0. So -3, 0 is here. When you plug in -2, it gives you the absolute value. This would be -4 plus 6 is 2. The absolute value of that is 2. When you plug in 1, -1, it gives you -2 plus 6, which is -4. The absolute value of that is, or it's +4, which the absolute value is 4. When you plug in 0, it gives you 6. Now, when you finish the rest of the table, you should see the symmetry. When you plug in, let's see, when my x value is -2, I get 2. X value is -1, I get 4. X value is 0, I get 6. And then the symmetry happens on the other side, and there is your absolute value graph. Your domain, all real numbers. Your range there, your graph starts at 0. There's nothing down here. It starts at 0 and it goes up forever. Number 3. To find, again, we got to be careful with this one. To find where your vertex is going to be, take the stuff inside the absolute value bar and set it equal to 0, not the whole thing. So inside I get x equals 0, so that's going to be where my vertex is located. So I'm going to do 1, 2, and 3 on one side. I'm going to do -1, -2, and -3 on the other side. When I plug in 0, when I find f of 0, I do the absolute value of 0 first. That's 0 plus 5 is 5. So 0, 5, 1, 2, 3, 4, 5 is right here. That's going to be my vertex. It's going to be easier to plug in 1, 2, and 3. And since I know it's going to be symmetrical anyway, let's do that. When I plug in 1, take the absolute value, you get 1. 1 plus 5 is 6. Plug in 2, the absolute value 2 is 2. 2 plus 5 is 7. 3 would be 8. You can solidify by plugging in -1. The absolute value of -1 is 1. 1 plus 5 is also 6. And you already know you're going to get 7 and 8 here. So you get 1, 6, 2, 7, 3, 8. And you can just use your line of symmetry to find these 3 over here if you would like to. And there is your absolute value graph. The stuff on the inside, 3x plus 2, let's set it equal to 0. Subtract 2. Divide by 3, and you get x is -2/3. Now this is going to be a little bit uglier. So -2/3. When I plug that in, 3 times -2/3 gives me -2. -2 plus 2 is 0. When I plug it in, I get 0. Now that's going to be -2/3, 0, which is somewhere right in there. So I've got a weird line of symmetry here, so it's going to be hard to match that on each side. Okay, we could try. But let's see what we can do here. Let's just do, let's see, on one side would be -1, -2, and -3. On the other side, let's just do 0, 1, and 2. And this is not going to match up with our line of symmetry just perfect, but we'll get a good graph here. Okay, so when we plug in -3, let me erase this. You get 3 times -3 is -9 plus 2. That's -7. When you take the absolute value, you get +7. -6 plus 2, when you plug in -2, -6 plus 2 is -4. The absolute value would be +4. -3 plus 2 is -1. The absolute value would be +1. When you plug in 0, you get 0 plus 2. The absolute value is 2. Plug in 1, you get 3 plus 2 is 5. The absolute value is 5. Plug in 2 gives you 6 plus 2 is 8. The absolute value of that is 8. So my graph is going to look like this. I've got -3, 7. So 1, 2, 3, 1, 2, 3, 4, 5, 6, 7 is right here. -2, 1, 2, 3, 4 is right here. -1, +1 is here. -2/3, 0, I already had that. 0, 2 is here. And you can see the symmetry is a little bit off. 1, 5, even though it is still symmetrical. 1, 2, 3, 4, 5, and 2, 8 would be about right here. So my graph is here, and I missed terribly there. Let's try that again. There. Okay, and your line of symmetry for that graph would be kind of over here, but you still can see it has that symmetrical quality. Number 5. The stuff inside, to find your vertex, set it equal to 0, and you're going to get x is -1 is going to be your vertex. This one will be easy to graph using that vertex. Pick a view values on each side. We'll go 0, 1, and 2 on this side, -2, -3, and -4 on this side. When you plug in your vertex here, -1 plus 1 is 0. You take the absolute value, then you do everything inside, then you take the absolute value, and then you put the negative in front of it. -1 plus 1 is 0. The absolute value of that is 0. Negative in front of it doesn't matter. It's still 0. So -1, 0. There's your vertex. Let's plug in 0. That's going to be easy. 0 plus 1 is 1. The absolute value of that is 1. Put the negative in front of it. It is now -1. So make sure, again, do all of this work first and then put the negative. Plug in 1. 1 plus 1 is 2. The absolute value is still 2. Put a negative in front of it. That's -2. 2 plus 1 is 3. The absolute value is still 3. Put a negative in front of it. You get -3. And you can check down here when I plug in -2. -2 plus 1 is -1. When the absolute value of that would be +1, put a negative in front of it. And you would get -2 and -3 here. So when I plugged in 0, I got -1. When I plugged in 1, I got -2. When I plugged in 2, I got -3. Because of the symmetry, you can actually go ahead and plot these points on the other side. So your V is actually, with this absolute value graph, got flipped upside down. Your domain is still all reals. Your range, however, changed. Your graph goes down forever. You have graph down here, and your graph stops right here. So your range would be everything from -infinity up to 0, and 0 is your vertex, so you will include it. With this one, I want to point out, now notice that you're doing 1/2 times x. I encourage you, anytime you have a fraction, especially being multiplied, pick some values it's easy to take half of, or to multiply by a half. So keep that in mind as you're picking your values for x. So 1/2 x plus 1, set it equal to 0. Move the half over, it gives you 1/2 x equals -1. To get rid of a half, we're going to divide or multiply by 2. Divide by a half, which is the same thing as multiplying by 2, and it gives you x is -2. So -2 is going to be my vertex. Pick some values on each side. When I plug in -2, half of -2 is -1. -1 plus 1 is 0. When you take the absolute value, it's still 0. When you subtract 4 from that, when you plug in -2, you get -4. When I plug in, well, I told you to do something that I didn't do it myself. If I were to plug in -1 here, half of -1, I'm going to get a fraction. So let's go back and change what we're plugging in. Let's plug in some even values so that when I take half of it, it comes out to be nice and clean. So that'd be 0, 2, and 4 on this side, -4, -6, and -8 on this side. And if you space it out, you still should see that symmetry. When you plug in 0, now we got to do everything on the inside first. When you half it, you get 0. When you add 1, you get 1. The absolute value of 1 is 1. Subtract 4 from that gives you -3. Plug in 2. Half of 2 is 1. 1 plus 1 is 2. Let's take the absolute value of 2. That's 2. When you subtract 4, it gives you -2. You see a pattern. Half of 4 is 2. When you add 1, it gives you 3. The absolute value of 3 is 3. 3 minus 4 is -1. And you can test that symmetry when you plug in -4. Half of -4 is -2. -2 plus 1 is -1. When you take the absolute value -1, that's +1. When you subtract 4, it gives you -3. This will give you -2. This will give you -1. Now let's plot those points. -2, -4 is your vertex, and I'm going to go ahead and plot the rest of them for you. And there's your V-shaped graph. And notice it's kind of flattened out this time, than more so than what it used to be. Now, I do want to bring up a point that might help you with your graphs here. I noticed the pattern between this. This part is linear. It has a slope, 1/2, 1/2, 1/2. This is also linear. It also has a slope. 1, 2, that'd be negative 1/2, negative 1/2, and negative 1/2. So if you'll notice that pattern, that might help you a little bit when you're graphing these. They will have the two sides, because of its symmetry, will have opposite slopes of each other. So my domain is still all reals. You can plug in anything you want to. Your range, your graph starts here. That would be at -4 at your vertex, and it extends up forever. So therefore, that'd be -4 to infinity. Number 7. We've got a piecewise function. So let's see if we remember how to graph piecewise function. Our division point here would be 4, so I'm going to take and I'm going to do a line at 4 to keep our two sections separated. The first part of my graph, I'm graphing in the section to the left of 4 over here. So I'm going to graph -2x plus 1, so my y-intercept is 1. My slope is -2 over 1, so I'm going to do some points down through here. And then let's see, what do I do at my line right here? Since we don't have or equal to, I'm going to do an open circle at my line. And then I'm going to extend my graph forever in this direction, so we can now connect our dots. And there's that portion of my graph. Now the other portion of my graph is actually an absolute value graph. Okay, so if you want to see what your vertex is going to look like, you could do x minus 3 is 0. That would be you're going to have a vertex at 3. So my vertex, my graph is actually over here in this section that I'm not graphing in. So if you would like to, though, you can still, you can put, let's see, when I plug in 3, if you do your table of values, when you plug in 3, you're going to get 3 minus 3 is 0. The absolute value is 0. So my vertex for my absolute value graph is going to be located at 3, 0, which is here. I did an open circle because that's not going to be part of my graph. I am going to take and I'm going to plug in points on one side of my graph, okay, on one side of my vertex. When I plug in 4, I get 1. When I plug in 5, I get 2. When I plug in 6, I get 3. Now, what do I do on my line? Will my line be portion of my graph here since it's or equal to? The answer is yes. So at 4, 1, I'm going to put a solid circle. At 5, 2, I'm going to put a solid circle. At 6, 3, I'm going to put a solid circle because those are parts of my graph. Now, over here would be the rest of your graph, which, again, that's in the portion that we're not plotting. So therefore, this part over here is actually going to be erased anyway. It's not going to be part of my graph. And this is what my piecewise function would look like. Your domain, what can I plug in? I can plug in all values smaller than 4 and all values above 4. So that'd be all real numbers. So that'd be all values from negative to positive infinity. What will I get? I will never get a value below this. Notice there's no graph down here. So my graph starts at, what is this value? 1, 2, 3, 4, 5, 6, -7. My graph starts at -7 with an open circle. And then it extends up. And notice because of the arrows, it would extend up forever. So there would be your range. Okay, the next one. Another piecewise function. My divisions are at 3 and 2. So I'm going to draw me some lines there at 3 and 2 to divide up my graph. And that's actually -3 and 2 instead of 3 and 2. Now let's graph our different parts. On the first region, everywhere x is less than -3, I have the function absolute value of 2x minus 4. You can set, again, for the absolute value, you can set the stuff on the inside equal to 0. That's going to be the vertex of your absolute value graph. Let's see, x and y. Let's plug in 0, and let's plug stuff in on just maybe one side of it. Let's do -1, -2, and -3 since I'm wanting to graph over here. Okay, so when I plug in 0 into this part, I know that 0 is going to give me my vertex. I have 2 times 0 is 0. The absolute value is 0. Minus 4 gives me -4. When I plug in -1, that's -2. Absolute value is 2. 2 minus 4 is -2. When I plug in -2, I get 0. When I plug in -3, I get 2. So let's plot those points. And again, reminder, I'm only going to graph in this region. So if it's not in this region, it's not part of my graph. So 0, -4 is not part of my graph. -1, -2 is not part of my graph. And now what about -2, 0? No, that's not going to be part of my graph either. However, -3, -3, +2, since it's or equal to, that is part of my graph, and you can see the pattern now. Now the other portion of my V shape would actually be over here. You see that? That's going to be my absolute value graph, but I'm only going to graph, you notice you can use the slope here. I'm only going to graph the portion that's in that first section over there. So these points are not part of my graph. I'm going to go ahead and erase those, and I'm only going to graph this portion. And that's the only new stuff. The rest of it is old material. From -3 to 2, I'm going to graph this horizontal line at -5. Let me scroll up. So 1, 2, 3, 4, 5. And that's going to be an open circle at here and an open circle as well here. And I'm going to graph that horizontal line. For x -2, for the last part, I am going to include 2. So that's going to be a y-intercept of -2 and a slope of 1. So these parts don't get included. Actually, that one does because I am including 2. And then I continue on and on forever with a slope of 1. So the rest of my graph would look like that. And I'm not going to include these 2 points, and there is my piecewise function. Now, which points or what values of x can I plug in? There are no breaks in your graph as far as x values that can't be accounted for, because this is all values from -infinity to -3, including -3. This is from -3 to 2, not including either one, but you do include 2 here and you go to infinity. So for as far as x values, I have them all. As far as y values, there's nothing here. Then all of a sudden I have y values here. And those y values are located at the single value of -5. So one of my range values is -5. And then I have more range values here on up forever. And that would be all values from 0. Now we include 0 because it is part of your graph, 0 to infinity.